I welcome everyone and a very good morning to all of you people. So before we go ahead and get started, let me take a minute to introduce about myself. Participants, I'm Siddharth. I'm basically an Azure certified data engineer where I go ahead and play a very vital role in my organization to help various teams who are dependent on data, like my machine learning team who needs data for their model development, model training, to that of my business analyst team that helps the organization to go ahead and make better business related decisions based upon the data that I bring. So during this process, participants, I get to go ahead and use a lot of tools and services for Microsoft Azure involving Databricks, involving Apache Spark programming, involving Data Factory, and so on. So I go ahead and primarily deal with the services of Microsoft Azure. So these services play a vital role in getting data to these teams and help them build solutions around them. And for these participants, my skills are of DP203 and DP600. So I am certified in both. So that sums about my experience. And I'm totally about 10 plus years now working on to these tools. Now, participants, what is the agenda for today that we are meeting up here? The agenda is, participants, very simple, that what Microsoft Azure has to offer towards data related, so that you can build your skills on data and use Microsoft services. Good. So this technically can be called as Azure Data Engineering. So I want to do data engineering around Azure. So the agenda now gets simplified by addressing the requirement as Azure Data Engineering. And participants, I know you have questions, so don't worry. I'll take your questions. First, focus on learning path. That means what path you are expected to take so that you can get learned about these Azure data engineering services, which I call it as learning path. Okay, so let's go ahead and first discuss about this learning path participants. So to address this learning path participants, we need to go ahead and get started to look at firstly the data that you are working with. What is the central component? The central component shall be your data for all of you. The moment data comes in, participants, we cannot guess unless until you get to see the data. So we have to max can differentiate by looking at the data that the data can be structured in nature or it can be unstructured in nature. At a very high level, I can broadly classify the data can be structured and unstructured. Example for structured, participants, standard employee table, employee table. What's this unstructured data? The data that is coming in the form of employee table, not a table, but say you can call it as a JSON file or a CSV file or a Parquet file given to it. Files are given to it. I hope participants, everyone can understand this basic classification, structured data and unstructured data. Participants, I hope now you can connect with the concept of structured data and unstructured data at very high level. Is that very clear? Now, participants, based upon this, you have to go ahead and decide where to go ahead and store this data. Now, our requirement starts to get broadly classified. Okay, now this is what I have to go ahead and address it. So you have to address two things while you address your data engineering, where you store it and where you process that data. Participants, for storage, you have to decide for what purpose are we storing. Are we storing for analysis? Are we storing for our analysis or are we storing for our processing? So this processing, we call it as OLTP, we call it as transactional. That means we store the data for transactions. But participants, we are not storing for our transactions, we are storing for our analytics. We are analyzing our data. So we have to decide, are we storing it for OLTP storage or OLAP storage? Participants, why it is important for us now to understand this logic? This logic is essential, participants. Why? Because if you go ahead and start looking at this logic of OLTP and OLAP, I'll come back to this. What is this OLTP and OLTP? OLTP means I get data generated and I store it in databases, like an application writing data to a database. For example, I get to see sales taking place, transactions getting recorded. So those data storage will happen as part of the databases. So what kind of those databases are? SQL databases. But participants, I don't need now to focus on OLTP system. I need to focus on OLAP system. So what I need? Data warehouses. So what I need, participants? Data warehouses. So at a very high level, participants, I hope you understood the OLTP. We we go ahead and highlight databases to store the data. OLAP, we store the data as part of data warehouses. Am I good, everyone? Participants, am I good? So whenever you come across any data engineering project, you have to go ahead and first understand that your data generally get to be seen in the form of structure or unstructured. Structured means you get to see standard tabular form. Unstructured means file formats like JSON, CSV, FAT formats. So now we have to decide what purpose I'm storing this data for. I'm storing this data because I have records to be created, stored. We address this by using databases. Else, for analytics process, we get to go and use data warehouses. That is the reason I just been highlighting the purpose of OLTP and OLAP. I hope OLTP, OLAP is very clear, everyone. Can we proceed a little further from here? Now
Yes,
that you have decided to go ahead and only use analytics, now participants, if you just go ahead and ask on the internet that if you are very much new to data warehouse, if you are not from data warehouse background, participants, you will see data warehouse. Even if you just go ahead and do a Wikipedia search, you will slowly and very soon you will realize that these databases have been designed to go ahead and handle only structured data. If you take some time, participants, and if you go through this documentation of Wikipedia documentation, and participants, if you try to go ahead and analyze this, slowly you will realize that, yeah, here, even here it is mentioned, OLAP and OLTP. You will slowly realize that these databases or these data warehouses are specially designed to go and handle your relational databases. So that is where data warehouses have been efficient for the last 40 years. If you get to see their placement, participants, they have been very, very good in managing the relational databases. Now, participants, why did I go and highlight this point? Because participants, just now I have highlighted that we have to address data that is storage that involves structured data and unstructured data. So, participants, now data warehouses, if you get to go ahead and use it, they can give you great support if your data is coming in the form of structure. Unstructured data, I don't think so. They have been evolving over a period of time, unstructured data. So now, participants, we need to go ahead and figure out a storage. Apart from data warehouse, is there any other storage that we can consider to store our data that can help you to store your structured data and unstructured data? Participants, let's go ahead and ask internet storage for, or let's ask our co-pilot because it can give you right answers. So let's guess that if Copilot can help us, let's get to go ahead and use Copilot and go ahead and ask it, what kind of storage should I go ahead and consider? What type of storage be considered for structured and unstructured data storage? Let's get to see its conversations. So it says that you can go ahead and get to use it, unstructured data, and participants, it is getting to go ahead and give us an option of, okay, it gave me consider for both. I'll ask for both at one place. Then participants, it is giving me an option to go ahead and consider Lakehouse unified data solution for addressing this requirement for the structured and unstructured data. So participants, now what is the suggestion that is given by the AI? The suggestion that is given by AI is to go ahead and consider Lakehouse. Now what is Lakehouse? Let's go ahead and break it down into two parts, lake and house. So participants, this lake is nothing but your storage that is being referred by data lakes, and house refers to data warehouse refers. Am I good to all of you people? Participants, am I good now? So participants, very simple logic is that now I have addressed two major things, data lake to store the data and data warehouse to process data. Now data lakes addresses what, participants? Both the storages, structured storage, unstructured storage. Structured and unstructured, both the storages have been addressed. Structure is addressed, unstructured is addressed. And participants, data warehouse has been now extending the support via lakehouse to support structure and unstructured. Am I good, everyone? Participants, am I good? Okay. Now I have received a request for OLTP. What is the full form? Online transactional processing. We are not into OLTP, rather we are into OLAP, online analytics processing. Now participants, if you get to go ahead and get to see now from the lakehouse capabilities, participants, data lakehouse. So we are addressing our storage here. We are addressing our processing here. So we address data by data lake. We are addressing processing with regards to data warehouse. Now participants, under the data warehouse, popular strategies that you get to see are of SQL. We'll go ahead and use SQL. Participants, for me, if the data is structured and if I get to go ahead and bring in the form of tables, SQL is good. But participants, as the data gets complex as a part of unstructured, SQL programming kind needs of data to be given a structure because the data is here unstructured. How can I go ahead and make it in a structured format so that I can go ahead and take a benefit out of it? So now participants, I have to go ahead and search on the internet. Internet, what are the top recommended engines for data processing? Now I want to go ahead and focus on data processing. Now participants, you get to see here Apache Spark standing on the top. So let's get to go ahead and also address Spark requirements. Now storage requirements is addressed. Now we are addressing the requirements through Spark, participants. So what are we expecting from a lake house? We are expecting from a lake house, participants, storage in the form of data lakes, processing in the form of data warehouse, extended support for SQL, Spark, and extended support for structured data and unstructured. Now, participant, here comes a problem. The problem is Data lake, as the name itself is telling you, it is defined to go ahead and store your data, storage, but we are running SQL. Participants, do you think SQL will run on storage? Do you go ahead and run your SQL queries on a storage, on a file? Participants, select start from EMP. EMP is what? A table, right? Employee table, right? EMP is not a file, right? You will not be able to process your data from a data lake. Am I good, everyone? Now, if you go and look at this, participants, this SQL is a kind of a query that you expect to run it on a database inside a table. But the problem is this is a storage. So how to address this requirement? Participants, let's ask the internet the same thing. How to address SQL programming with Azure with data lakes. How to address SQL programming with data lakes. So participants, do you get to see it is asking me to go ahead and address the following solution, which is data. Now participants, here is a game changer. Mr. Delta has come into picture. If delta comes into picture, participants, then what exactly is this delta is all about? Let's go ahead and look for delta.io. That is the answer, participants, that I have been awaiting, and this is the point that I've been awaiting for all of you to come. So participants, now this is the time for us to go ahead and focus on building lake houses using delta. That means the delta is the one that is expected to go ahead and take us to the next. So participants, I know these things do not go ahead and make very much understanding at the start of the session. What I want you to understand from this entire discussion, participants, what is that I want you to go ahead and understand from this entire discussion is this. The industry is moving from traditional data warehouses. That means this is somewhere around 15 to 20 years old technology that has been there. This is getting replaced by modern lake house design. Modern lake house design. So in modern lake house design, what you get to see, participants, in your modern lake house designs, you should expect the following. What is that you should expect, participants? You should expect data lake. You should expect data warehouse. You should expect SQL programming. You should expect Spark programming. You should expect Delta capability, and so on. There are many other things. Let's not go into the details of this. But for now, at a very high level, I gave these are the resources that I need. And that is where participants, the popular lakehouse technologies that are available. So I'll ask, please list popular lakehouse this from Microsoft Azure or popular lakehouses. I want to get to see what are those popular lakehouses. Okay, fine, participants. It understood lakehouses very different. Then participants, here are the lakehouse cap. Databricks stands on the top. BigQuery from Google, Microsoft Fabric, and Azure Synapse. Participants, these are the top lakehouse capabilities which you find under your Microsoft Azure. If you navigate to Microsoft Azure, and if you look in Microsoft Azure, participants, you will see the Spark capabilities offered by Databricks, Azure Databricks, and Azure Synapse Analytics. Are you with me, everyone? Participants, are you with me now? So Azure Data Lake House is now being branded by Azure Databricks and Azure Synapse there. So now participants, your entire journey is around Databricks and Azure Synapse. Now the question comes is, can I go ahead and start using data lakes to store the data? The answer is yes. And that is where participants, now if I go ahead and ask data lakes, do you offer data lakes? It says yes, I do offer data lakes, storage accounts. See, we are able to retrieve a service that matches our requirement. Can I get to go ahead and use SQL? Yes, you can go ahead and use SQL. SQL compliant databases. Spark is available. SQL compliant database. These are our OLTP systems. In OLAP system, you will get to see participants Azure Synapse. You'll get to see Azure Synapse. Next, very important point is that we have addressed storage. But participants, did we address movement of your data into data warehouse? How do you move your data from data lake to lake house? From data lake to warehouse, how do you move the data? Or how do you move data from source to data lake? I need to move the data, right? So I here have to extract the data from the source, transform the data from the source, and load the data from the source. Before I use Databricks or Azure Synapse participants, I have to extract the data from source, transform it, and load it. So I'm really dependent on a service called ADF. It stands for Data Factory, Azure Data Factory. So participants, before you start using Databricks, you need to bring data from your source, Data Factory, ADF. So participants, now you see we have the services that are getting listed. So what are the services till now we have been listing? The services that we have been still now listing. If you get to go ahead and give a summary, we need Azure Data Lake to store the data. We need Azure Data Factory participants. We need uh, Databricks to process. We need Synapse. We need SQL programming. We need Spark programming. This is about your journey participants for your data engineering. This is the learning path that this learning path is being sponsored to you participants by Visualpath in this data engineering format. And you see here participants, you'll get to see the same concepts that I've been highlighting: data factory, Synapse, and Databricks. So if you look at by modules, introductions starts with data factory. You'll be learning about data factory, concepts around data factory, working with data factory. You'll get to start handling pipelines with sources like SQL, NoSQL databases, logging and monitoring for the changes that you get to see, pipelines getting triggered, transformations. Yes, transformation is a very vital subject in data flow, that is through mapping data flows. Post that, your journey with Spark and SQL will start. We can use Databricks or Synapse. So we'll go ahead and get to see Synapse, then into Databricks, complete Databricks till Delta and real-time streaming. That's how people you will get to go ahead and take advantage of this learning path to meet up the requirements here. So let me take a quick minute to summarize it because a lot of things have gone by. And then participants will get started to have our queries here. Participants, will you be able to memorize all this? I'm sure it will be very challenging for all of you to memorize. Let me give a simple tip and make it easy for all of you. Participants, don't memorize everything. Just memorize one keyword which should help you. So what is that keyword I want you to memorize? The keyword that you will memorize from today onwards is data And the moment data comes in, you should get to see storage to store the data plus processing of this data. So this one can be perfectly handled if you get to go and use Lakehouse. That means Lakehouse involves data lakes plus data warehouse to go ahead and process your data. So you'll get to see data, storage and processing. Storage is addressed by your data lakes. Processing is addressed by your data warehouse. So in this data warehousing, you will get to process SQL and Spark Cap. If you memorize this much also, you are good. And what services in Azure you will get to see? Databricks Synapse are the services. How do you get to go ahead and handle the data storage, data lakes? How do you go ahead and get to move data between all the services, data factory? And certain other suggestions for you if you want to memorize for data visualization, Power BI, and with regards to streaming, you will get to see structured streaming capabilities. And if you want to go ahead and use Databricks, a little bit of Python knowledge to go ahead and process your data. That's all. This is what is a summary of the agenda participants. Now, if you are clear with the agenda and participants, drop me a quick yes and then I'll start taking your questions. If you have understood it, participants, could you confirm with a quick yes into the chat? Thank you very much. Let me just start taking the questions one by one. So let me take the question number one. What is the full form of OLTP? The full form of OLTP is online transactional data processing, which is already been highlighted. Let me just one more time highlight it to you. So OLTP is nothing but we get to see transactions taking place, insert statement, delete. So a method that helps you to store your data by inserting, creating, deletion of the records. Okay. Next question that I get to see is Delta Lake a kind of RDBMs designed to hold unstructured data after this? For now, net, the answer is right. It is kind of a storage plus a database put together that will help you to store not only structured data but also unstructured data by having a transaction history maintained. So, what your point is somewhat right, but not 100%. But for now, understanding purpose, I consider Delta Lake is nothing but a storage for unstructured data plus your transaction history. Manash, I hope that answers your question. Next, appreciating for the class. My question is, are the mentioned skills being standard for every data engineering process? Do we need coding? Okay, let me get to use this now from AWS standpoint of view. So in AWS also, we have to go ahead and if we are using not Azure, if we are using AWS. So in AWS also, we have to go ahead and process the data. That means I need to address storage, I need to address processing. That means I should go ahead and build lakehouse. Data lakes I should have. So in AWS, we get to go ahead and store the data in data lakes involving AWS S3. Data warehousing, Spark and SQL, you get to see services like Apache, not Apache, what is that? Athena service. You get to see this one using Redshift, and there is another service called EMR. That's it. So here services have been very specific to the cloud provider, but the process is the same when you compare to AWS and Azure. If you want from GCP also, in data lakes in GCP you use GCP DL data lake, Spark we use BigQuery, and Spark we use Dataproc from GCP. GCP. See, process is same in AWS, process is same in Azure, process is same in GCP. Only thing that has changed is your services from cloud provider has changed. Yeah. And do we use Python for coding here? Python is not for coding. We don't do coding here. While we talk to Apache Spark, I'll tell you the story behind our very simple. Participants, Spark is something that you will go and work day in, day out. Spark. Now the problem with the Spark is inside your memory. That means inside your RAM. Can you talk to your RAM in a natural language? No, you cannot. You have to write codes of zeros and ones and zeros, which humanly I can't write it. So for that reason, what I do, I used a programming language like Python and send all my instructions in Python to Apache Spark. So we need someone to interpret this human language Python to this binary language, which can be used by RAM to make Spark run. That is where we go ahead and use something called PySpark, Python plus Apache Spark, PySpark, right? So here we don't do coding, we just use Python as a medium. So a little bit of Python will help me how create help you, right? Rajesh, for data processing from storage, what resources you use effectively to connect with data lakehouse? That is where my answer is Data Factory, a factory module from Azure Data Factory that helps me to connect with sources. There are about 100 plus sources that you can code and use. Connect with them, move your data into data lake, and from there you can start using with regards to your data processing. So you can start processing your data. So Data Factory is greatly recommended here, Rajesh. You
Hello.
have questions? Yeah, please go ahead, Manash.
Yeah, hi, sir. Good morning. Sir, I have a question here. Actually, you said that Azure Data Factory, Synapse Analytics, and Databricks, all the three things are required. So, is it something like that? Okay, they are dependent with each other because Azure Data Factory, I think it's a kind of a tool which is does ETL kind of an activities, but the Databricks, it is the PySpark and Spark. All these things are integrated together. So how these two things are means related or not related? I don't understand.
Okay, forget about Databricks, forget about Data Factory for this for a minute. Let's understand a simple and real world example. That's something which can
Mm.
you
Okay.
generally go to a store, or let's say you went to uh, common store supermarkets, right? So when you go to
Mm.
supermarkets, what you get to see there? Nice display of items pulled. So let's say you want to go and buy some products for your stationery. You go to stationery section and you buy from there. Now for this item that you are buying from the factory, from where it is manufactured, right? It has gone through a process, right? It has come through a process, correct? It has come through
Okay.
a process. That means even in the factory also, it might have been some raw materials. That means there has been some raw materials that has been taken from the world. All those raw materials are brought into factory, processed. The item is processed. So let's say another example is water. Drinking water is another good example. That means they should have taken this raw water from somewhere, cleaned it in the factory, and some truck company might have bottled these companies and brought it up to the supermarket, and supermarket it is displayed for your purchase. So now the point is the raw materials that you had. Let me get to go ahead and give the analogy of it. So if you get to go ahead and look at this data, now the data which was given to you, or the waters that I am referring to, has been of raw water. That means data, if you get to see the analogy, also it was raw at that time. So what you have done processing of it at where at your factory. So waters, raw water. So the data is also raw. You brought it to the factory and you processed it. So for this movement, who helped you? The factory, data factory helped you to process this. After the processing, the water bottle got bottled. That means you got your processed data like processed water, and then participants from processed water you are bringing to the store. Which store? Supermarket for this. So I'm bringing data now to data warehouse. So what I'll do at the data warehouse, I'll run my SQL queries or I'll run my Spark queries. So this data warehouse supermarket concept now you can replace with Databricks. Databricks is the place where you go ahead and run your SQL queries. Supermarkets is a place where you go ahead and purchase your products. I hope this analogy is helping you, Manas.
Mm, yes, yes, sir. Sir, I was just thinking on something like that. Okay, the SQL and the Spark means SQL. How does it going to be different? Because SQL is it's a query language for fetching up the data from the relational or database object. Uh, Spark does what? Uh, it's something different. It is also useful for experiments, querying the data from the relational database kind of stuff, or
Okay,
what
Manas,
it does.
I'll
It's
answer
like
your
if,
question if you don't mind. I answer your
yeah.
question. Spark is your big data processing engine that
Mhm.
extends support for SQL also. That is the answer. So it is an engine to do big data processing. Plus, it extends support for speak. You can run SQL queries also. Okay,
Okay.
right. Uh, Let me take. If you don't mind, I'll come to you, Manas. There are other people also. Just I'll finish them and I'll come
Yeah,
back to you.
yeah, yeah. Sure, no problem. Thank you.
Will this course involve participants? This we will get to go ahead and use Radhesham, real data from the internet. We process it, then we go ahead and get to solve the real world problems. For this, you have to go ahead and practice inside your account and you will get billed for it. See, I'm using a Databricks compute account and I'm using it for data processing. So you have to go ahead and process the data with real world data. So that's how you will get to see the real world data getting solved. So it's not only me that you also have to go ahead and practice it. Okay. What does Databricks exactly? Databricks, to answer your question, Nirjal, Databricks does go ahead and process your data using SQL programming, Spark programming. So here you see in my account, it does go ahead and support your processing involving compute for SQL and Spark, and it does go ahead and help you to handle your data movement, data transformation, SQL programming, Spark programming, Delta programming. Okay, Nirjal, I hope that answers your question. Can you show a quick demo for data analysis or deployment? Here it is on your screen now. You see here I have been building paths for data movement, data transformations. So I'm addressing the data movements, data transformations, connectivity with regards to data pulled from sources involving unstructured data like involving files like departments and CSV files. Okay, Nirjal. Rajesh, will it be presented using whiteboard or PPT? No PPTs. I don't like PPTs at all. I like only going ahead and presenting in live console. I prefer console method. I don't want to spend time on PPTs. PPTs are whenever I need it, I just can go ahead and summarize it in the form of a PPT, but I don't like PPTs at all. I prefer to go ahead and do hands-on, complete hands-on. I want to prefer. Okay.
Mhm. Siddharth, I have one question for you.
Yes,
Will you cover only concepts wise? Like a real time, how we are using those concepts? So, will you cover the real time project or something parallelly on each concepts wise?
asking this question same, I'll get to give you the same answer. It is that you have to
Okay.
get started with your own account. You have to create
Okay.
your own account. You have to go ahead and practice in your own account where you will get billed for it also. That means you will be have to make payment to Microsoft Azure for using these services.
Yeah.
When you get to go
Uh,
ahead and do the practice into your account, you will first understand the concept. But to understand the concept very well with your practical approach, you have to go ahead and do a practice along with me by giving necessary practice at regular intervals of time. And that will be the session for every day. Every day, we will get to go ahead and practice the concepts that we go ahead and discuss. For example, if I'm discussing a concept called delta. So it is a concept that I will go ahead and discuss with the participants, and then I'll go ahead and get started to practice. For example, I'm discussing a topic about, let's say, Databricks. In Databricks, I'm discussing a topic about Databricks file system. It's an important topic. So with regards to Databricks file system, what exactly we are expected to do in Databricks? So I'll go ahead and give a discussion about it. What is Databricks file system? Then I'll go ahead and give the essentials of what is Databricks file system, followed by how to go ahead and address the contents of it, solving a real world problem, addressing the movement of your data, real world problems, and making the data available from one source to another source, creating resources, creating directories. So solving a problem from the real world perspective involving the real world data that we get to go ahead and use it. So this way, your perception towards one concept at the start of the session might not be very clear. By end of the discussion of the session, by highlighting about the hands-on, it will be very clear. I'll also expect that you will also go ahead and not only use my data sets, you can use outside data set for your real world practice. Hundreds of tons of data that is available on the internet. You can download it, you can practice it. If you get stuck somewhere, next session when you come up, if you ask me, I'll be able to help you out that where exactly are the mistakes have been committed. So I'll be able to go ahead and give you a correct reference of it. But here the important thing is these services are not free, they are paid services. So you have to balance out your practice accordingly for the topics that we go ahead and discuss, the hands-on that we go ahead and do, and the data that you get to go ahead and use. I hope that answers your question, Santosh.
Yes, so this course is only 35 hours. So even you'll cover it all real time scenarios. This also it will include only 35 hours.
The standard content for Azure Data Engineering is 32 hours only, but extra 3 hours is kept in case if there is some kind of issues that are expected to get addressed. People asking like you asking questions or questions, and also some kind of time to go ahead and spend to explore it. So standard content is 8 hours in a day multiplied by 4 hours, 32 hours, not even 32 hours. Actually, it is 28 hours, but we have extended to 35 hours because we have to accommodate questionnaires, we have to accommodate issues, we have to accommodate some topics to be discussed. So some extra 7 hours are kept. So optimally 28 plus 7, 35 is a good number to get started. Don't worry about those things. It is my responsibility. Why is that you're worried about my responsibility? Okay.
No, I just want to check. So will you cover the real time? So it will be helpful to us. Only concepts wise, we can get it somewhere. So I need the real time how we are using it and what kind of issues we'll get.
You're
If
not understanding what is my point. My point
yeah, I
is
understand. I understand.
I'll not be using concepts here. I'll be making you to concepts. I'll be going ahead along with the concepts. I'll be going ahead along with the concept presentation, concept discussion, and concept presentation in the form of a hands-on. You have to do
Okay.
along with me. You have to get to do a practice along with me. If you don't do that,
Yeah.
you
Okay.
will not be able to understand the next subject.
Yeah. Okay.
Participants,
Yeah. Good.
any other questions you have for me? Participants, do you have any other question for me?
Uh,
Yes, sir.
Hi Siddharth. Hi Siddharth. This is Radhashyam. Hello.
Yes, yes, I'm listening to you, Radheshyam. Please go ahead.
Okay. So Siddharth. So will it involve? First question is, will it involve any real-time project? Means like it will start from the source till the means deployment. Means deployment is fine, but at least still means how we're processing in Databricks, right? And idea that thing.
Okay,
And
I'll make
second
it
thing is,
very clear.
second question is, will it involve the delta live tables or also or not?
Okay. Now, participants, we will get started by taking data, bringing data into various sources like SQL databases we'll use blob storages, we will use data lakes, and we'll also use Cosmos DB. That is NoSQL databases. These are our OLTP system. Movement of this data will happen from these sources into your primary data lake through data factory. And also we will use Synapse participants. This will address your data movement. From data lake, we will be getting to go and use Spark. For this, entire Spark learning needs to be spent. We need to go and spend time in Spark learning Apache Spark. Once you are comfortable with the Apache Spark, then only we will shift to Databricks. And Databricks is the place where we will get to go ahead and use a lot of services, Databricks services, SQL programming, Spark programming, SQL data warehousing. Then we will get to go ahead and see with regards to Delta Lake capabilities, handling Delta tables. So once this is done, participants, then we will shift to Synapse. And in that Databricks participants, there is another topic which is not been highlighted, which is called streaming, which is something which is missing in most of the content. So I just made sure that the streaming is also addressed. Then we will get to go and do the same thing with the Apache Spark, Azure Synapse also. See the journey that we are traveling, data movements involving data factory from sources, from data lakes to Spark programming, their Databricks and Synapse. So that's a complete 360 degrees that we will get to go to. I hope that answers your question, Radhishyam.
So we can put it as a project, right? Okay.
Correct. So we get to go ahead and do by taking some data outside. What I would suggest you participants, you bring your own data sets. Get some data sets on the internet. Get that. You try to solve a problem with it. That means you are able to go ahead and solve a problem of a bigger project. So that's how you will be able to learn things by yourself as well. Only thing is, my role at that time will be helping you to guide you that this is how you should follow, because you anyhow practice it. You will get to see in the sessions. You will replicate with your own data sets.
Okay.
Yes, Radhisha, that answers your
Yeah.
question.
So Siddharth, yeah. So Siddharth actually means I have set up the Azure portal and all those things. Okay. But what is happening, right? So during the setup, right, some of the settings are not working because we are doing in a not a real time environment, right? So some of the settings it says okay, some errors are coming, right? So we need your help to resolve those things also, right? So that's what. So that is also one thing I wanted actually.
Fair, noted.
Okay. Yeah. Okay.
Right. So, participants, then let me give a quick summary for today, what I wanted to go ahead and discuss with all of you. Participants, the journey of data engineering is very, very interesting. It's very fascinating also. Now, the problem in the real world is, participants, data is growing. People are being hired by organizations to handle data. And there is a strong competition in the data engineering field also, participants. Now, how I want you to outsmart that competition is you have to be very good and strong in your Spark programming. What is meant by this Spark, participants, is that if you get to see standard contents that are available on data engineering, they will never be able to highlight about Spark. But participants, we will try to get to see the best of the skills that we can go ahead and do. So participants, we will try to get to go ahead and with the best of the skills towards Apache Spark. If you are good in Spark, participants, you can outsmart most of the competition involving data engineering. This is my sincere and personal suggestion to all of you. So, Databricks services, all these are fine, but as much as you become good in Spark, you can work in any. You can work in AWS services, you can work in Azure services, you can work in GCP services, because all the three services use Apache Spark. You should be good in Spark. Should be your focus. Data engineering will get solved automatically for you. And participants, that will be the primary purpose of this data engineering. So that's it from my side, participants. I hope you have learned something better out of this session. If you have further questions, you can get to go ahead and reach out to the Ambika or Malti, who will help you to get your questions answered thoroughly. That's it from my side, participants. I'll take a leave for today. Thank you, everyone, and have a great weekend ahead. Signing off at this side, Siddhartha. Thank you, everyone.